Hello everyone and welcome back to the channel. So today we are going over the sixth example in the Basics of Static Equilibrium series. So for this problem, it's actually very simple, and it looks deceptively hard because you've kind of got like two beams going on top of each other and all that, but it's actually very simple and only will take us a minute to solve if you understand kind of the fundamentals going on here. Okay, so first thing you want to do, always identify what your reactions are, all right? So that's AY and then AX because that is a hinge support. We got CY, this is a roller, DY and DX, and then finally will be BY, all right? So 1, 2, 3, 4, 5 reactions. All right, so to solve this, it's actually very simple. You just follow the force down. All right, so let's just start with the top, right? The top, BY and DY. All right, so okay, so let's do sum of forces in the y direction, and upwards equals positive, and set that equal to 0. All right, so basically, if you aren't familiar with the triangle, it's basically a ratio, right? So this is a 3, 4, 5 triangle. You can use trigonometry to solve this as well, but in this case, all you would need to do is it's a ratio, right? So if 25 is this diagonal over here, right, then proportionally speaking, that this would be a 3 and then this would be 4, all right? So 3 would be 15, and then 4 would be 20. So that comes from 25 divided by 5 times 3 and then times 4 respectively, all right? So kilonewtons and kilonewtons. And these are just the force, this 25 broken down into horizontal and vertical forces, all right? So we're going to take this vertical part and we're just going to solve for Fy. So we get By plus dy equals 20 kilonewtons, right? That makes sense. Two reactions, one load, and we all know that intuitively speaking, if you just have a load in the middle, it's symmetrical and therefore it's equal, right? So as you can see here, this only applies when it's symmetrical, by the way. When it's non-symmetrical, as you will see later, you would need to just do a moment balance like what we've been doing so far, right? So since this is equal, all we need to really do is just say By equals 10 kilonewtons and then dy also equals 10 kilonewtons, and then we can move on, right? Sum of forces in the x direction of this top beam, okay? This top beam would just be dx plus 15 kilonewtons equals 0, and we're just doing this because of the sign convention, and it would tell you that dx equals negative 15, all right, which means that dx is actually resisting it in this direction, right? Which makes sense. If you push it to the right, something's got to push it back to the left, all right? So once you have that, the trickiest part of this problem actually just is this portion over here. You might initially think, okay, what the hell do I do with this? Well, it's actually very simple, right? Since your By is resisting 10 kilonewtons up here, that means this force has got to be transferred like into the ground, right? So intuitively speaking, you would also have 10 kilonewtons applied right at this point, okay? Let me just undo that. So it might be a bit hard to see, but bear with me. This is just the 10 kilonewtons from the By, right? That's being transferred to this beam on the bottom. Okay? Now, if it is a bit hard to see, actually, let me just copy paste this, right? Let's just copy paste this for your guys' clarity. So, we ignore the top, and then we just apply 10 kilonewtons at this point, which is 10 meters from A and 5 meters from C, okay? So now this is very simple to solve. It's just a standard beam problem. We can just do sum of moments around, let's say, just point A counterclockwise, set that equal to positive, and then equal that to 0. And then finally we have this 10 kilonewtons pushing it clockwise, so we would have negative 10 times the distance to A, which is 10 meters, right? And then plus cy, because it wants to spin it counterclockwise, cy, and then 15, right? Distance from A equals 0, all right? So that's 100 divided by 15, which nets you cy equals 20 over 3, or that is roughly 6.67, right, kilonewtons. All right, so once you have this, you can just do sum of forces in the y direction on this beam. Okay, so that's equal to AY plus CY equals 0. Equals 10, excuse me, right? And, 10 subtracted by 20 over 2, that's 10 over 3, which equals to roughly 3.3 kilonewtons, okay? So that's how you get AY, CY, and for your sum of forces in the x direction, all right, if to the right is being positive, you can just intuitively tell that AX equals 0. Why? Because if this point at B is a roller, that means it's not transferring any forces like it is in the vertical direction here. Instead, it's all being resisted by this point D, okay? So that's actually just it for the problem, right? So we've got we have got this dx value going to the left because it is negative, this cy value going upwards, and then finally AY and AX, all right? So again, it might look like a tricky problem, but it's really not. It's more intuitive than anything. All right, and more examples to come. But yeah, if you found this helpful, that's great. So more videos to come, and I'll see you in the next one. Thank you guys, and bye-bye.